So our topic is geometry, and we have an overall question first. What is geometry to you? Can we have a few volunteers raise their hands and tell us what they believe geometry is? Diana?
Geometry is related to shapes.
Shapes. Anybody else?
It's not calibrated again.
Okay. So, shapes. Anybody else?
Faces of a shape.
Angles. Okay, good. Faces, angles.
Polygons.
What?
Polygons.
Polygons.
So dimensions, like 2D or 3D?
2D or 3D. So basically what we talked about last class and part of last week, I guess, we had started a unit on geometry. Can I move on?
Mm-hmm.
Do you want to say anything?
So, if these are the things that we typically think about, we're going to focus on the things that we don't typically think about when we think of geometry, and how geometry can be integrated, how it's a very diverse content area, and it can be integrated into different content, into different subjects, and it can be used in all grade levels.
Just clearing, yes, you're clearing. Press the clearing. Closing clear.
That's on the top, right? Thanks.
You have to do it on the computer, probably.
And then next, there you go.
Not that great with SmartBoard yet. Okay, so why is geometry important to teach?
So, as you very well know, we live in a three-dimensional world, and what this means is that geometry is everywhere, and we need it in order to apply mathematics to real-world situations. Because if you're thinking about planting a garden or something like that, then you're using geometry in that kind of application. Also, it relates to spatial awareness and spatial thinking. So students are able to place themselves in the world and understand different planes and other aspects of geometry in that sense. And problems.
And then just in problem solving, if you think about, somebody gave us an example. Well, like if you're saying, I want to build a vegetable garden, and it's in the shape of a rectangle, and I wanted to split it up into, we have 4 vegetables, and each one wants to have equal parts. So that's geometry in a way, but then that's also related to fractions, which we're going to get into later, of how geometry often relates and correlates with other content areas in mathematics. Okay, so the history of geometry. In Egypt, ancient Egypt, the Nile River, it often overflowed, so the ancient Egyptians had to build around the Nile and help to establish the boundaries and the size around the land to help that. So they had to measure length and determine the areas and the boundaries of the river. Also creating the pyramids, that's geometry right there. Oh, sorry. I'm good at this thing. Placing the stones in the right place to create the pyramid shape and to have that also, it doesn't like collapse and all that kind of stuff. And then the Babylonians measured the circumference of a circle, but they said that the circumference was 3 times the size of the diameter, but that's a little bit off from today's measurement. And we talk about pi a lot for 8.14, so I'm sure you guys heard of as we got into the later grades. Okay, now the Greeks. Euclid is considered the father of geometry, and that's a picture of what they think he looks like. He assembled of what we know today as 3D geometry, and he created books called the Elements, and there was 13 books altogether, and they talked about mathematical knowledge spanning arithmetic, geometry, and number theory. But his main focus was primarily on geometry, and when he was studying this, he gave more than just explanations. He used logic and he used proofs behind all of his theorem, and that's what made him so influential. And then there's Pythagoras, and he's known for the creation of the Pythagorean theorem, which is, a squared plus b squared equals c squared with the right triangle and its sides and the hypotenuse, angles, hypotenuse, all that. And then there was Archimedes. He he developed a method for finding the volume of irregular shapes.
Okay, so as we were researching, we also came across the Van Heel model. I don't speak Dutch. So this is a theory that describes how students learn geometry. It originated in 1957 in the doctoral dissertations of Dina Van Heel and Pierre Van Heel, they were husband and wife, at Utrecht University in the Netherlands. So the model has greatly influenced geometry throughout the world through emphasis on analyzing properties and classification of shapes at early grade levels. So within this model, there are different levels of understanding geometry, kind of similar to developmental stages. And at the highest stage, you're at a level where you can understand geometry in relation to all mathematical concepts. But the important thing about this model is that it focuses on the importance of integrating geometry into lower grade levels and using it across subject areas. In the United States, the theory has influenced the geometry strands of the standards published by the National Council of Teachers of Mathematics, so NCTM, and the new Common Core standards. So that this model heavily influenced both of those.
Okay, so geometry in various grade levels. When you think of geometry, I know when we first got the topic, right away I thought of high school geometry. In class geometry, there's a Regents just for geometry. So a lot of people think of it as just in the higher grade levels, and that's where of just those things that we discussed earlier. But it exists in all grade levels, K through 12. So starting out with basic shapes and 2D, 3D, faces, angles, and all that kind of stuff. And then as we get older, move across grade levels, we go into more stuff like doing like the whole I didn't even hit it, trigonometry, and just finding the angles and the degrees inside a geometric shape. So examples are perimeter, area, classifying shapes, and congruency.
And these are all concepts that will grow and be scaffolded as students get older. So perimeter can be introduced at very early grade levels, but it will also be a concept that becomes more complex and more developed over time. Same with classifying shapes, congruency, and other topics like that. So geometry across disciplines. In many other countries, mathematical subject areas are not approached separately because the disciplines naturally intertwine. So again, when we think of high school mathematics, a lot of the time those subjects are separated. So you take algebra, and then you take geometry, and then you take trigonometry, probability, and statistics. But within all of these content areas, there are overlaps because mathematics naturally intertwines. So when we encourage problem solving rather than procedural-driven instruction, there will be a natural integration of all the disciplines. So if we teach with using inquiry-based strategies, then that's where we're going to get the natural integration, which is what our goal is. So examples are fractions.
Go ahead.
Sorry, with fractions, basic algebra, trigonometry, measurements. These are all topics that will naturally intertwine. So like in your presentation just now, when you were doing the measurement with the clocks, there were, you could use the units as a pattern, and then I said to Nikki that it's just kind of like her presentation because she was looking at analyzing patterns in algebra.
Okay, so we focused on first grade. So teaching geometry in first grade, they focused on classifying shapes, so distinguishing between defining and non-defining attributes. Defining meaning a triangle has 3 sides and it's a closed shape. Non-defining attributes are color,
Orientation,
and
it's turned a certain way.
and the overall size of it.
So that's where you might find some alternative conceptions in students if they think that color is a classifying attribute.
Like a red triangle versus like a green triangle. They might think that's 2 different shapes, so that's one of the main focuses of first grade. You want to go?
Mm-hmm. We also focus on allowing students to compose 2-dimensional shapes or 3-dimensional objects rather than simply classifying these things. Students can create and compare their shapes, and this can be done using tangram pieces, I think you said we call them, or pattern blocks, just like the ones that we have. So rather than just